Integrate tan inverse root of 1 minus x upon 1 plus x with respect to x. With reference to these various types, let's now try to integrate this new function. I'm going to simplify this inverse function using a trigonometric substitution. In place of x, I use cos 2 theta. Once I replace x as cos 2 theta, I have to replace this x also, dx also. For that, let me differentiate dx. I need to differentiate cos 2 theta. How will I differentiate cos 2 theta? Derivative of cos 2 theta is minus sin 2 theta into 2. Into 2 because of the chain rule. Now this dx and the x, when we replace in the integrand, it will look like this. Tan inverse of root of 1 minus cos 2 theta upon 1 plus cos 2 theta into this minus 2 is kept outside. The remaining sin 2 theta d theta is written here. Now, how to get rid of this ones? We are going to replace cos 2 theta formula, trigonometric identity. And we will put different ones in numerator and denominator so that this one could be cancelled. I apply 1 minus 2 sin square theta for the numerator, 2 cos square theta minus 1 for the denominator. Both are formula for cos 2 theta. How will it work? This 1 and 1 will cancel here. Here this minus 1 and this plus 1 will cancel. So we are left with only this much. After cancelling the 2's, we are left with root of sin square theta by cos square theta. That is tan theta. Tan inverse of tan theta, we were waiting for it. So tan inverse of tan theta, theta, and sin 2 theta, which we brought from the derivative part. So the integration of this inverse function is now in this form, which we clearly observe to be a product. Product rules are integrated using integration by parts. Product rule. First function into integral of second minus integral of derivative of first into integral of second. That is what the by parts method say. So let us go ahead. First function into integral of second. Integral of sin 2 theta with respect to theta is required to be written. How is it written? First function theta is okay. Integral of sin 2 theta. According to the formula, we have to write the integral of v, second one. Yes, I have written this with the help of this formula. Integral of sine of a first degree polynomial will be minus cos of the first degree polynomial upon the derivative of that polynomial. What is the polynomial here? 2 theta is the polynomial. The derivative is 2. So minus cos 2 theta upon 2 here. Same once more. The formula says the integral of v comes once more. Here also the same. Now, integration is not complete. We need to proceed further. You have to complete this integration. Before that, let us just simplify this step by giving this 2 inside. Minus 2 multiplied, this become term positive and the denominator 2 got cancelled. This minus 1 minus 3 times minus, this term will be minus and here also denominator 2 is gone. Much simpler stage. Now, one more integration is still left. Due to this one, the product is no more a product, now a single term. Now, how to integrate cos 2 theta? Again, using that very same pattern. Integral of cosine function, first degree polynomial is the angle. Then, sine of the polynomial upon the coefficient. So, cos 2 theta integral is sine 2 theta by 2. So, the integration is complete. Once the integration is complete, now we need to replace all the thetas, all the variable theta back to variable x. How? Our substitution is cos 2 theta. And we have cos 2 theta over here. It wasn't cos 2 theta. This sin 2 theta is now changed into cos 2 theta so that this substitution could be replaced by x. So, before I put that, I'm going to take LCM of these two terms so that I would get instead of theta, I would get 2 theta, which will be more convenient for me to substitute back. 2 theta is cos inverse x. So, this 2 theta will be cos inverse x. Cos 2 theta is x Another cos 2 theta, that also x. Everything going to be replaced in x. So cos inverse x into x minus root of 1 minus x square. Cos square 2 theta is x square. Now, one more simplified step, taking this denominator 2 as half. Cos inverse x into x I have replaced, rewritten as x into cos inverse x minus root of 1 minus x square plus c. C is the constant of integration. Found it useful? Don't forget to subscribe Maria Joseph channel for variety of examples and various topics.